Hello everyone, and welcome to my very poorly done explanation of the first page of the vector addition sheet. Now keep in mind the number one thing for this sheet is that it's just like the thing that we did in lab. The only difference is this is now very Regent style questions. So you can see the question numbers for this are pretty random. That's because all I did was copy and paste them from different Regents exams so you can see what these questions are like. And it's just a good overall review. Now, quite a lot of them will have a very similar process to go through them. There's just some subtle differences that you really need to pay attention to. The number one thing to really look out for is which way or how the arrows are connected. Most often, there'll probably be the tail of another arrow is attached to the tail of another arrow, which is just like the what we had in lab. And the trick to this, if we remember from lab, was to simply move one of them to the other side, draw it, and then go from there. Now, sometimes it will actually already be moved for you, and they want you to make the mistake of moving it back, but you just have to pay attention to see how they're lined up. Are they tail to tail in this case, which is something that we need to fix, or is it tip to tail, which is already done? Now, the first question in quite a lot of these involves generally the scale. Sometimes they give you the scale, sometimes they ask you for them. Now, for this, you'll need to have a ruler, so you need to measure this length and this length. Now, quite honestly, I'm not sure how the copies came out, but on the original Regents exam and how I tried to make these copies is this one should be about 8 centimeters long. Excuse me. And this one should be about 6 centimeters long. So hopefully they're somewhat close to that, but I can't confirm they are. So if this is 8 centimeters long and it's 80 newtons, that means that this is a 1 centimeter to 10 newton ratio. Now the next question asks us to actually make the drawing. Now for this you absolutely need a ruler. Unfortunately, I don't happen to have one on me and I'm drawing on a computer screen to begin with. So I'm just going to try to freehand it. But you definitely need a ruler to get the full credit. Now, how I'm going to do this is I'm going to do it in 2 steps. I'm going to move one of these over. It doesn't matter which one you moved. We showed that in lab. I'm just going to move the 80 over, and I'm just going to draw it as a dotted line. Doesn't really matter how you draw it. This is kind of a showing your own work situation. The goal is you want them to be the exact same length and the exact same angle. Luckily, the angle is pretty easy to do because it's just straight up, but you'll notice that on some other pages, some of them are actually angled off to the side. And forgive my freehand here, but there's my line. Now, in order to get full credit on one of these questions, a very important thing that you need to always make sure you include, and you'll lose all the credit from this question if you don't, is an arrowhead attached to the vector. A vector needs to have the magnitude, how long it is to be correct, but it also needs to have the direction. Without the arrowhead, it could mean it's going this way or the exact opposite way. That's why the arrowhead's important and why I included it on here. 53, you actually have a choice. It's up to you. You can measure the length of this, use your scale, and figure out what the answer is that way. Or you can do some math because this is a right angle, and keep in mind this will only work if it's a right angle. You can do a squared plus b squared equals c squared. If you do that, you get an answer of around 100 newtons. Now, you can be slightly off from that because our drawings don't have to be perfect, but it should definitely be close. Same here. You can either use a protractor to measure the angle that's asking for, or you can do some math if you know that that's 60, that's 80. You can use tan to get the answer. And if you do, you should get 53 degrees. Now that's overall how to do the first question. I hope that you guys can figure out the rest of it. Just obviously make sure you're careful for the wording. Watch out. I don't have the paper in front of me, so what order it is, but there is one that has you actually draw a total of 3 vectors and kind of deal with that. Just kind of keep in mind, work slowly, make sure you do it neatly. That's pretty much all I have for today. Hope you guys have a good one, and I hope to be back by the end of this week.